Hi everyone and welcome to Algebra 2, lesson 2.3b. Let's go ahead and get started. So what this lesson starts with is a warm-up from 2.3a and I believe 2.2 a little bit. So I'd like you to go ahead and work on 1 and 2, which we will go over in class. All right, now vertex form of an absolute value function. So the vertex form of an absolute value function is going to be written as f of x equals a absolute value of x minus h plus k. So basically, this value, this form, is going to tell us where exactly the vertex, right, where the vertex of an absolute value function is. So where is that point of an absolute value function? So your vertex is actually located at h and k. Right, so now you see how we have an h right here, and there's an h right here. And then there is a k right here, and a k right there. I know it doesn't look like a k. It almost looks like a k and an e at the same time. All right, let's just make it a k. There we go. It's a k. All right, so now this a that's over here, let's give that a friendly color. Let's go light pink. A is the slope on the right side, and then negative a is the slope on the left side. So remember, there's a slope. So then we have a negative a. That's also going to be the slope on the right side. Remember slope, remember rise over run, rise over run. All right, so let's go ahead and look at this. How do we use this? Well, I want you to remember this one phrase again, okay? Add to x, go left. All right? Add to y, go high. Right? If you could remember that, that's going to help you out. So basically, when I look at x, right, the vertex form of x, see how x minus 2? Am I adding to x? No, I'm subtracting to x. Well, if I was adding to x, I would go left. So, but since I'm subtracting, I'm going to go right. Well, how far right? I'm going to go right 2. So from here, I'm going to go right 2. Now, this right here, that tells us where our y is going, okay? And now we're adding to, when it says add to y, go high. Well, we're not adding, we're subtracting. So we have to go down 4. 1, 2, 3, 4. So right here is our vertex at positive 2, negative 4. Right now, how do we go ahead and figure out what the rest of our absolute value function looks like without going crazy here? Well, you notice there is nothing in front of the absolute values. Suddenly it's an invisible 1. Well, so that means the slope on the right side is just 1 over 1. The slope on the left side would be negative 1 over 1. So if you think about it, right, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And the slope on the left side is going to be the same thing, except the opposite way, which is going to wind up being a negative line. So like this. So then when you go ahead and graph it, your absolute value function would look like this. So the slope over here, m, the slope of this is negative 1. The slope on this side is positive 1. All right, so let's go ahead and try one more. Now, when I look at this right here, I see that I'm adding to 5. So when I add to x, I go left. So that means I'm going to go left 5. So 1, 2, 3, 4, and 5. So I'm going right there. And now notice that there is nothing being added here or subtracted. So that's just like a 0 plus 0. So we don't move it at all. So right here is my vertex. So over here, my vertex was 2, negative 4. right? That's your vertex. Here my vertex is a negative 5, 0. And you see that my slope is 3, so 3 over 1. So that means I go up 3, 1, 2, 3, and over 1. 1, 2, 3, and over 1. And I do the same thing on the left side. I go 1, 2, 3, and over 1. And this is what my absolute value function will look like. Right, so this really isn't that bad if you just look at what's going on here. Right, so in class, oh, we're missing the other page. Hold on a sec. Okay, I was able to find my second page of these notes. So I'd like you to go ahead and right now do 3 through 6 is what I'm going to ask you to do in class, and I'll come back to it later. So number 7 is a piecewise function. All right, so we don't have to worry about vertexes too much. We can just go ahead and graph this like normal. Right? So 4x plus 2 when x is less than negative 1. So we can use like our t-table and put a negative 1 in there. And we have a 4x plus 2. So, oops, sorry, this is my x, this is my y. I have a negative 1. So 4 times a negative 1 plus 2. Negative 4 plus 2 is a negative 2. So negative 1, negative 2 is right there. Now, we can go ahead and determine that we have a slope of 4x plus 2, so a slope is 4 over 1. Right? So technically, I don't even have to do this t-table if I don't want to. I know that my y-intercept is plus 2, and I'm going 4 over 1, so 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. But going down, I'm going 4 down, 1 to the left. 4 down, 1 to the left. 4 down, 1 to the left. But what happens is that we know it has to be less than negative 1. So if I go ahead and look at this, I see that negative 1 is this line right here. And I know it has to be less than negative 1, so all of this can't exist. And in fact, it's less than negative 1, so even that doesn't exist because that's going to be an open circle. And your line is just going to kind of do one of these. So that's that one. How do we graph this one here? Well, this is negative 3 times the absolute value of x plus 3. So when you think about it, since this is going to be negative 3, right, x plus 3 means we go left 3. And there's nothing over here, so we didn't go up or down. So 1, 2, 3, that technically is our vertex. Now our slope on the right side is down 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So technically, right here, this is going to be our absolute value function on this side because it can only be where x is equal to or greater than 1. So this is what it would look like down here. All right, why don't you go ahead and try number 8, and we'll go over that together after. Finally, number 9 and number 10. Okay, those are inequalities. Okay, and if you remember, inequalities are like shaded areas. So remember, like if it's greater than, you might have this area that's shaded. If it's just like this, you would have a dashed line where it's not full. All right, so let's go ahead and try number 9. So number 9, we can find our vertex because we're at plus 4, so that means we're going to go negative 4 on the x. And our y is going to be negative 6. So that's our vertex. Negative 4, negative 6. 1, 2, 3, 4. Right, there's our vertex right there. And right here, there's nothing in front of here, so our slope is 1. Same thing on the other side, slope of 1. So this right here is our absolute value function. And you notice it said y is less than this. So it's going to be a solid line because this has the equal sign over here. And since y is less than, this part is below, so that's less than. And that's your answer just like this. And I'll let you guys do number 10. All right, so we'll try this in class, and I'll go ahead and continue the video for those of you that missed class or want to rewatch. All right, let's go ahead and handle 3 through 6 now. Right? So basically, when I look at this, right, this tells me that my x actually is going the opposite, right? When I add to x, I go left. So this is going to be left 1, and this will be down 2. So I go left 1, down 2, and that's my vertex. It tells me my slope coming on the right side is 2 over 1. So 2 up, 1 over, 2 up, 1 over, 2 up, 1 over, 2 up, 1 over, and that's how my absolute value function looks. And my vertex is at -1, -2. On number 4, I see that there is nothing. It's like plus 0. So this tells me I am going to go right 6. So it gives me plus 6, 0. So that is my vertex right there. My slope is technically -1. -1 over 1. So I'm actually going down. That's my slope on the right side. And when I do it, it's going to look like this. Number 5, I see that I'm going to be at -1, -1, which is right there. So that is my vertex. It tells me my slope is 2 over 3. So I go 2 up and 3 over. 2 up. The key is if you miss your mark by a little bit, just make your thing bigger. Right, and there you go. That is your absolute value function. Over here, I see that there is nothing being given to x, so it's just going to be 0, 7. So I go 0, 7, which gets me right there. That's my vertex, and my slope is -3, 4. So down 3 over 4. Down 3 over 4. And this is what my absolute value function is going to look like. Number 8, we have a piecewise function. So let's go ahead and color coordinate this real fast. So now we have it color coordinated. So I'm looking at the green, and I see that the green is less than or equal to -4. So here is my -4. I know I'm going to have a solid circle, and it only exists on this side. So when I go to graph this, I see that I am at -1, +5 is my vertex. So I go -1, +5, gets me right here. And I see that it's upside down, and my slope is -1, 1. Now, I can start doing this, but you see that by me going on the right side doesn't help because everything has to be on the left side of this line. So I'll just go down this way. And that is where my function starts, over here, just like that. Now, for the blue, it's between -4 and 2. So between -4 and 2. And they're open circles. And it just says it's 3. So when I look at 3, it's just going to be 3 and look like that. And then my pink one or purple one is on the right side. And the slope is, the equation is -x plus 7. So that's just like the y equals mx plus b. So 7 is my y-intercept, which is right there, and my slope is -1. So I go like this. All right, now I can't have it any of these because it has to be on the right side, and it'll look like this. And number 10, right, this is that inequality. It shows me that I am at +5, +4. So I go 5 over and 4 up. That's my vertex. Tells me my slope is -2 over 1. So I have to go down 2 and over 1. And it's going to look like this pretty much. Now, this says greater than, right? That's the greater than symbol. So greater than means above. So I'm just going to shade this area above my lines. Okay, and that'll wrap it up.